Good evening, everybody. Tonight's class was supposed to be on setting up color light cards, but the presenter had other commitments, so Kevin stepped in and he's going to teach us how to do some networking. Take it away, Kevin.
Awesome. Well, thank you. So this is did this a couple years ago for Light Up Ohio and went over pretty well. So this is we're gonna do just a real basic intro to networking, talk a little bit about some show network topology, show off how we do it here for our show, and then do some Q&A. So a little bit about myself. During the day, I work doing commercial audio video control systems. So think theme parks, stadiums, convention centers, conference rooms. If it can have audio video control, I do it. So I deal with very large networks with some fun things like PTP and sub microsecond timing stuff. So networking is something I deal a lot with. I do a lot of training for us on it. So hopefully I know a thing or two about hooking some wires together. Um, my neighbors and I, we run the Lucy Depp Park Light Show. It's a 10-acre, 8-house drive-through. It's got roughly 247,000 channels. It's all pixels. We wrap about 400 or 500 trees with pixels. Um, and it's all synchronized together. So that, takes a massive network to pull that off. Um, you can look at our website. We got some videos and stuff on there. It's ldplights.com. So today we're going to go through what makes a network, how devices communicate in the network, how to build a light show network, and talk about some different topologies for that, and then Q&A. So what makes a network? So network really is just two or more devices connected together sharing data. So telephone system is a network. The internet is a bunch of networks. It's really just how we send data from one thing to another. So when we think of our home, everybody should know this good old trusty router. You probably had one, or in my case, about 10 of these over the years. So there's a bunch of different pieces that all make up a typical home network. So you have your cable modem, your router, cabling, Wi-Fi access point, Ethernet switch. These all could be combined into one box. It could be multiple boxes, but we're going to go through and just sort of break out what all these different boxes are. I'm trying to see where I lost my notes, but we'll do this without notes. So first part is cabling. We use both for networking data and even, when you're talking to differential receivers, we use what's called category twisted pair or CAT cable. There's a bunch of different types of it. So there's unshielded twisted pair, shielded twisted pair. When you go to buy it, you can see plenum, riser, direct burial, UF resistant. It all has different ratings. All those are basically the different types of what kind of jacket and core is in them. So you can see that Cat 5e there has pretty much nothing. It's just a bunch of 8 twisted wires together with a piece of plastic around it. Shielding adds a wire or a foil tube around it to help prevent interference. Plenum and riser are just designations for inside of buildings. So when you're dealing with commercial buildings, plenum cable, if the building catches fire, doesn't kill people as quickly. Riser cable is what your normal cable is. The cool thing for us in Christmas lights, it doesn't really matter what we do. So we go through miles and miles of cat. We buy the most basic unshielded riser. Depending what's on sale, we might get UV resistant, but it honestly, we're in the woods, it gets covered by leaves really quickly. So, and then there's different ratings for speed. So 5E, 6, 6A, 7, 8, all that. All that means is how much crosstalk between the pairs is acceptable, which translates to how much data you can run. You can run a 1 gig network on 5E, no problem. It's starting, but it's 5E is still pretty prevalent. It's starting to get, you're seeing 6 more and more available. If you're running stuff through your house, it's going to be permanent. I've run 6. But for what we're doing, especially communication between controllers, 5E is perfectly fine. The biggest thing to avoid is copper clad aluminum. So that is a way to cheap out on the copper on the inside. They take aluminum, they dip it, just the outside of it in copper. It's just extremely brittle. It doesn't hold up well. It's not worth the couple cents a foot you'll save on it. For ends, everything's RJ45 ends. We can have a whole hour-long debate if you should use pass-through or not use pass-through connectors. But that's basically the connectors we throw on the end of these cables to make them. So the next piece is a router. Routers connect multiple networks together. Your cable modem is really just technically a router. It's used to connect local networks to the internet, connect local networks to other local networks. So if you're in a corporate setting, or if you're running multiple networks within your house, it allows those two to talk to each other. It's sort of the main brain of the network. And you typically, unless you're doing some real special cases, have one of these per network. Most scenarios, this will also contain what's called the DHCP server. And when we talk about IP addresses in a little bit, we'll talk about what the DHCP server does. Then we have Ethernet switches. So this is how we connect multiple wired devices together. They used to be, way long time ago, we had Ethernet hubs. Those have all been replaced by switches. You really, if you're still running a hub in your show, you should use a switch. But so we use the switch sends data between devices on the network. Data is only sent to the port that needs it. So if I'm sending something from my laptop connected to port 1 to a controller on port 4, it's only going to go out port 4. It's not going to go out 2, 3, 5 through 10 in this example. So it helps isolate some of that. There's lots of different things when you get into Ethernet switches. There are managed, there are unmanaged. There is the ability to provide power to devices. That's called PoE, or power over Ethernet. We utilize a lot of that in our show. But for the most part, you're just connecting a bunch of controllers together. You can go out, just get a very basic, unmanaged, standard switch. There's nothing we do that really needs a managed switch. There's some nice things you can do with it, but sometimes you can get in more trouble than not by using a managed switch. So if you're just looking to go buy a switch off Amazon, just search, Netgear, D-Link, and any one of those brands, unmanaged switch, and you can get it anywhere from 5 to 48 to 96 ports if you want to go real crazy. Next part that's usually combined in those is Wi-Fi access points. So this is how we convert hardwired networks to wireless. Most consumer versions are built into your router, but you can buy external access points. They're all rated by a spec, so it's 802.11. That's the IEEE standard. And then it has a letter after it: A, B, G, N, A, C, A, X. Now there's phase 2, Wi-Fi 6. They keep coming up with more and more fancy names. All those really do are rating the specs. So the how much throughput it can handle, how many multiple antennas and everything. Those specs really just determine how fast your Wi-Fi access point can go. We're at a point now, almost any any modern one's going to be an AC, an AX. It's probably going to be able to perform way faster than your incoming home internet. So usually not an issue you run into with speeds anymore like we used to back in the 802B or G days. So one important point, and we'll talk about this when we get into building show networks. The max speed is shared by all the devices. If I have 300 devices in my house connected Wi-Fi, I'm sharing all of that amongst all those devices. So that's one thing when we get into planning network topology, you got to think about is how many devices are connected. Does it make sense to add more wireless for show data or hardwire them? So let's get into how devices communicate within a network. So we went over the hardware layer. This is really sort of the software layer of it. And we're going to do some very basic analogies here of sending some letters. So if my house is right here at 123 Main Street, in the computer world or in the networking world, that translates to an IP address. So IP address is made up of 4 groups of numbers. They're called octets. Each one can go between some can go between 0 and 255. We'll talk about some of the rules in a second. So each one of those can be between 0 and 255. There's some rules around that. But in my case, we'll say my laptop is 192.168.1.123. So some of those rules. Local network must be within a private range. So this is anything that runs within your house. If you set up a show network, if you set everything static, you want to keep it within one of these 3 ranges. If not, there's something else out on the internet, probably on that address. And if your network can reach the internet, you'll start having issues. So 10.0.0.0 through 10.255.255.255. So basically 10 dot anything, 172.16.00 through 172.31, 255, or the ones that you most commonly see used in home networks, 192.168.0.0 through 192.168.255.255. Anything outside of that is free use for the public internet. So if I go and set up a bunch of controllers and I decide I want to use 8.8.8.8, I'm going to have issues because that happens to be Google's DNS, and it's going to really confuse my router what to do with that. On the same address, you can't have duplicate IP. So I can't set 2 devices to 192.168.1.2 and set my laptop to that and set my controller to that. It won't go well. It'll get really confused about where to send those packets to. Typically, and especially in home networks, .1 and .255 are reserved. So in most scenarios, and I'll preface this, if you're running an enterprise-esque network, you might set this up different. In most scenarios, .1 is your router, and .255 is what's called the broadcast, which is where just group messages go out. So you don't want to set anything into one of those 2 IP ranges. And when we hand out IP addresses, you can either set it, which is called static, or you can do dynamic IP address. So almost every network will hand out an IP address if you have a router. That's called DHCP. So that is, I plug my laptop in, it says, hey, here I am, give me an IP address, and the router gives me back that IP address. There's typically a range of IPs that the network will hand out. So it's not going to hand out every IP. In my scenario, I hand out from .100 to .200 as DHCP IPs. And then that way I have a chunk at the beginning and a chunk at the end that I don't have to worry about being handed out. If I set something static, most routers won't know it exists there. So if I set a controller to .101, and that's within my range of dynamic IP addresses, there's a chance my router will give that out to another device. After a certain amount of time, routers will automatically renew that lease, depending on the router. Um, it might give it back the same IP address. It might wait a certain amount of time. Um, in my case, I use a router called pfSense. It will try to go through the entire uh, pool of available IPs before it reuses one. But you see this a lot where you set up your show for Christmas, everybody gets an IP address. They're constantly renewing because they're always online. And usually renewal periods about some are a day, some are 7 days, some are as short. I've seen as short as an hour. Um, but at least once a day, that device has to say, hey, I want my IP address back, and the router gives it back to him. Put everything away for winter, though, plug it in next year, and everything gets new IPs because the router's either been, some will lose that when they reboot, and the router's been rebooted since then, or that device just hasn't been connected to the network long enough, the router forgot about it. So, how do you combat that? If you don't want to set it static, you do something called a reservation. So, a reservation, every network device has what's called a MAC address. It is 8 hex characters, so between 0 and 8 or A through F. And it's split up into 4 pairs of 2. And you just log in your router and say, take this MAC address and always give it this same IP address. And that's how I ran our show network for years. If we get some time at the end, I'll talk about what we've transitioned to now. But that is a really good way to make sure devices get the same IP, but that you're not going to conflict with something on your network. And the disadvantage of doing stuff static is you got to go in and manually set the IP of every device. And if you decide to change stuff or move stuff around, you got to go touch every device. So a little more work involved doing it static. There's no performance difference if you do all static. There's nothing wrong doing it that way. It just requires a little more work when you're setting up the devices. So let's start sending some mail. So I want to send a letter from me at 123 Main Street to my neighbor at 125 Main Street. So in that world, I want to send a packet of data from my laptop at 192.168.1.123 over to another laptop at 192.168.1.125. So how does it know, hey, I can do this? We add in the second piece of information. So there are 3 pieces that really make up setting up a network. First was our IP. Second is our subnet. We're going to keep it really simple today with subnetting, either 255 or 0. So anytime you see a 255, it means ignore this, or don't communicate past this. Anytime you see a 0, it means communicate to all 255 addresses on that network. So in this case, I have 255, 255, 2550. So I'm going to ignore the first 3, and I can talk to everyone on my last octet of IPs, which means my computer can talk from 192.168.1.1 all the way to 192.168.1.255. So in my case of sending my packet, my computer goes to send it. It knows its subnet. And it goes, hey, this is right here on my local subnet. Really easy. I'm just going to send it right out to my local network because I know that device is available there. But what if I want to send a letter out to Google? Google doesn't live on my home network. I need to be able to send it somewhere that knows where Google is. And that's where routers come into play. So a router acts like the post office, where I can take my letter, I send it to the post office, and then the post office knows what Google's address is and sends it on. Now, in the case of the internet, there's probably multiple steps of this happening, but we're going to keep it real simple for this example. So computer still 1.123. Google happens to be 172.215.15.110. At least when I wrote this a couple years ago, that's what it was. So I need to go to my router in between. So my router sits on two networks. It just so happens in this magical example land, my public IP of my router happens to be in the same subnet as Google. It makes it really easy. So I send my packet to dot one, and we'll talk about what that is in just a second. And then the router translates that packet, says, hey, I know Google is 172.215.15. I'm in that same range. I can talk to that. And it forwards it on out to Google. So what's that third piece of information? That is the gateway. So the gateway typically is the IP address of your router. In almost every home network scenario it would be. And this is where if I'm trying to send a packet out and it's not within my subnet, send it here. And then from here, it's up to that gateway or router to then figure out where to send it to. So a couple rules, and gateway then is our gateway out to the world. So couple rules with gateways. Gateways aren't required. If I'm just setting up a bunch of controllers on a network, I only need to give them an IP address and a subnet. Gateways are really only required if I need to communicate outside of that network. So if I have a FPP player I want to send out and be able to hit the GitHub update server, it needs a gateway on it. A device should only ever have one gateway. That gets really important when one of the topologies we'll talk about in a second is using the Pi as sort of a router. You don't want to define gateways on both the interfaces on it because it will confuse the device. So even Windows doesn't really like it. Windows has some ways it works around it. But really, you should only ever have one gateway defined on a device. And so with those three pieces of information, that's how we can sort of build the software layer of how we communicate on a network. So how do we translate this into building light show networks? So first off, why build a show network? And I'm sure if I ask everybody sitting in the room here, everybody would have a different opinion on this. This is really my thought on it of why building a show network rather than just plug it all into your home network. It's easier to manage, troubleshoot, and configure. I can take this down and not take the house down. Coming from having two small kids and a wife that love watching Netflix, if I go and completely hose my show network, I don't have a screaming parade of people coming after me because I took down the home network. In addition, it helps keep some of that data separate. So like we said, Wi-Fi has to share everything going through that access point. If I am streaming from a player out to a controller, I really don't want to be sharing all my Megatree data with Breaking Bad on being streamed out to a tablet. So just because the router may support that bandwidth, the packets will get delayed or lost. There's a term I deal a lot with at work in networks called jitter. Jitter is unplanned spikes in network data. So when I start streaming a new show, when a computer does a software update, anytime there's a burst in data, the network has to accommodate for that. How does it accommodate? Stuff slows down a little bit. And so jitter is really hard to plan for. If I have a very bandwidth heavy network, I can plan and live around that. Jitter is very hard to plan around because it's so sporadic. What does that do to a light show? It causes your lights to slow down, especially if I'm not doing FPP players in sync mode. Jitter can be a big issue to deal with. So keeping everything separate just makes it a lot easier. And survivability. Say Spectrum, Comcast, whoever pushes an update, hoses your cable modem. If your cable modem is also your access point and your router and everything driving your network, and that gets hosed, there goes my show. building a dedicated show network makes it a lot more survivable. I can lose all that side. My players may not be able to go get updates, but I it still goes on. The show still goes on. Um, so let's look at a couple of different topologies of ways to build networks. I'll talk about some thoughts on each one. Here's the most basic way to do it. Go buy an Ethernet switch, go set a couple static IP addresses, throw your controller, throw your show player, whether it's a Pi or computer or whatever, throw your laptop on it. This will work perfectly fine. Just go in, statically set the IPs. There you go. Couple notes with it. Like I said, you probably have to set everything static unless you have a DHCP server. You're not going to have DHCP, so if I plug my laptop in, I got to remember what IP to set it to. But this is the most simple, foolproof way to do a network. It's very hard to mess this up. There will be no internet access on this, though. So if I need to push updates, if I'm on my laptop and I need to go look something up on how to do something, that's sort of the downside. Now, one nice thing, if I'm doing a laptop this way, I can probably still connect Wi-Fi back to my home network and do it that way. But this is a very, very simple, cheap, easy way to just isolate your show into an easy way to run. The next way is you can use, if you're using a Pi with FPP, you can use it as a gateway. So I can actually set up my Pi to basically act as a router. It's going to connect to my home network. My laptop connects to my home network. And then I have a separate network. We can see my home's all running on .1.x. My show network's running on .2.x. And I can run all the show network isolated there. That way, anything happens on the home network, it doesn't mess up my show network. So you definitely need different IP ranges. You will really confuse that Pi if you don't. You can't really directly access devices on the show network unless you connect to it or enable what's called static routing in Windows and really use the Pi as sort of a second router on the network. I've seen a lot of people get tripped up on that, so it's doable, but it's not great. And make sure when you do this, only the home network has a gateway set on the Pi's networking config. Otherwise, it's not. Linux has a really hard time knowing where to send packets out of that. My sort of preferred method is just go get a router for your show. So we see here, I've got a little router. I've got an Ethernet switch connected to it. All my controllers connect to it. I can connect Wi-Fi to it, or I can hardwire connect to it. And in the case of this one, and I'll show some examples of this guy, this can actually then connect wirelessly back to my home network. So if we do this, when we do this, you probably still want to set your show devices either to a static or reservation. That way they always get the same IP, but make sure that's not in the DHCP range of what you're doing. Or if you're doing a reservation, you can do it within the DHCP range because the server's aware. If the router you're adding has Wi-Fi, make sure it's on a different channel than your home Wi-Fi. Otherwise, you'll have some collisions. Routers have gotten really good these days, or access points, I should say, of channel scanning and searching, but you just want to make sure, especially if you'd manually set that, they don't sit on the same. And then your show router can be connected to your home network to get internet access for the show. If you do that, you want to make sure you're giving out different IP ranges. So if my home router gives out 192.168.1 dot, you want to set your show router to give out something else, 192.168.2 dot. That way they don't conflict. And that way, if say I do plug in Ethernet from my laptop to the show network and connect Wi-Fi to my home or vice versa, I don't run into an issue with that. So the little router I showed, those are GL-iNet. These are great. They're really low cost. You can see these are all their current models, and they range anywhere from $30 to $120. These things are awesome. I've got a fleet of 60, maybe 70 of these deployed at work. They travel the country in demo kits. They hold up. They have a really simple interface, but there's a lot of power behind them. And they've got a lot of nice features, like they can Wi-Fi join a network and also hand out its own Wi-Fi. They have a dedicated hardwired uplink if you want to do that. They're just really powerful, easy to set up routers. You can find some of the old. I picked up a bunch of the last generation ones for a little side project I was going to try with doing lights for like $12 off Amazon Warehouse. So they're really cheap, especially if you hardwire your controllers. You really don't need crazy Wi-Fi on this, so that basic $33 one can handle a lot of stuff. So, and then you can just dive in real head deep and go in like our show network, where we have a 10-acre drive through, so we have a lot of stuff. This is only half of it. But we're doing a whole massive Wi-Fi point to point. We have access points. We don't run any controllers on Wi-Fi. Everything goes out. We have a bunch of managed switches. There are 20 cult controllers throughout, almost, I think, 16 or 14 or so are K40s. We standardize on Netgear switches. We've got access points just for accessing it, but every controller is hardwired. So that's where you can go when you start really diving down the rabbit hole of networking. So, and with that, I'm going to open it up for questions. Let me find my Zoom windows.
Anybody have any network questions for Kevin?
Yeah, I have one for you.
Sure.
So I have my show at home. I also have a piece of property across a not a real busy street, but across the street. So I have a barrier. I my only
Yeah.
and I am gonna put some props up over there, and also a mega tree. I was actually looking at the ubiquity,
Yeah.
um, so that I have point to point. So do I necessarily all my controllers are all culp.
Yep.
So if I want to make sure I'm understanding this correctly. So since I have a card, the show is on each of the controllers.
Yep.
All I'm transferring is timing, correct?
Correct. Yeah. It sends, somebody correct me, I believe it's one packet a second. It's a very small packet. It basically says, here's the show file. Here's the sequence I'm playing. Here's the timing. Um, and here's what I am. It's a very teeny packet. So that's exactly how we do it here. So if I come back, we originate everything. Everything comes from here. So we have a tough book that's running FPP that all it does is stream out audio and act as our master. It sends
Okay.
that packet out. This is connected. Um, Here we have a big sort of centralized Omni, but if you're just going point to point, you could just do two of these little nano stations. And all these controllers are getting during the show is that one sync packet. So it FPP can send it out either multicast or broadcast. It doesn't really matter either way you do it. Some Wi-Fi will block multicast, which is why they do broadcast. But yeah, it's just sending that one packet, and that's specifically why we went all culp with everything we're doing. Well, that and we needed lots of differential outputs. But to keep it easy for us, so the only thing really running across our show network during the show is that sync packet, and then we're doing a lot of API hooks for monitoring. But
So are you
it keeps
running?
the data way down.
See, I don't see anything that's basically connected your Wi-Fi home system to this network at all.
Nope.
Or am I missing that?
So this is my home network here, but I'm running a
Okay.
completely isolated VLAN. So VLAN is a way you can basically make virtual networks. So I've got 10 of them throughout my home. So in our case, 10.0.60 is our light show. It's basically in a completely isolated network, and everything just communicates that way. The only reason we have access points throughout here is to be able to go out and like pull up on our phones, or when we're out configuring, be able to configure the controllers. So once the show's up, I really could pull out all the access points. We don't use them at all. Everything just runs as an isolated network of, and that's one thing I'll point out. So these ubiquities we're talking about, these are not your typical home network access points. AirMax is a commercial line of Ubiquiti products. It's used for wireless ISPs. So if you're out in a rural area, you'll see. I'm trying to see if I have a picture. I think I just used the same one ever. A lot of them look like little dishes. They're used to provide internet over vast distances, tens of miles. These little pill-like ones, these work great. I've shot these a quarter mile before. Where's Roland's house here used to be about a quarter mile throw throughout the neighborhood. They send it at very, very wide bandwidth. So I can't connect my phone to it. A normal, these things run at 80, I think they can even go up to 100 megahertz wide. They run very, very wide bandwidth, and they're very directional antennas. And that's how you're able to get much greater throughput. So once leaves fall, like right now, because we have leaves up everywhere, the data rate sucks. But I can usually pull anywhere from, I think our weakest connection is like 60 by 60 meg, all the way up to 600 meg by 600 meg, and we're still shooting through trees. So it's a very high power way to link stuff. If you're close enough, you could try throwing an access point and then another access point to bridge on the other side. But these nano stations, let's see if they came down. They got stupid expensive during COVID because of parts shortage, but they used to be about $50. They're now they're back down. So you can get it for about $53 off Amazon. Yeah, so they're real low cost. I mean, there's guys here selling kits of them and everything. So they're real easy. We've used here. I'll pull it right. We primarily use these little guys, the NanoStation AC Loco, because I don't need much more. We've had to, in a pinch, like run to Micro Center. They sell nano beams. I think there's some dish-like one. I have a dish one on my roof just because. Yeah, I've got one of these light beams. Just because that was during COVID, it got really hard to get these. So whatever was available is what we got. But really, the difference between a lot of these is really in the antenna design. So this is designed to be much more directional. We have an Omni, so we have basically a huge circular antenna that all these point back to. But you can build a very basic network, just two of these facing each other point to point. That's how we started out when it was just two houses. And then we keep adding houses and getting more and more every year.
Great. So what I was going to do is so let's say my K16, that's the one that's going to be running, that's going to be the main controller. Run that into a hub to all the other controllers, plus to the Ubiquiti.
Yep. Yeah, and that's how we do it here. Our main one is here. In this case, this is my one neighbor. He's got two switches tied together. He's got two. Actually, I know there's a couple more. He's added some more now. But he's got 4 controllers wired up. here, and then we just shoot wireless out to everywhere else. So, you know, as we add a house in the neighborhood, they buy an antenna, a switch, and however many controllers they need. So, and we know almost everybody's going to expand, so that's why we do a switch. You could just go straight from the AirMax. The AirMax needs what's called passive PoE. It comes with a little injector, but you could go straight from the AirMax down to whatever controller you have across the street.
Mm-hmm.
I would spend the $30 and put a switch there, because when you walk over there with your laptop and you need to change something, you don't want to have to unplug and shuffle, and just put a switch there. You will thank yourself.
Yeah, I was planning on doing it. Yeah, they're not expensive at all.
No,
Hey,
they
hey, Kevin, I definitely appreciate it. Thank you.
yeah, no problem.
And this is Pat. For those of you that use FPP, if you open up the FPP manual starting at page 169, there's all sorts of different documentation on different networking scenarios, from just letting it sit on your home network to these separate show network scenarios, and then how to set that up in FPP. But it's all documented in there.
That's awesome.
Kevin, I was waiting for other questions, not hearing much though. So you're doing 5 gigahertz on your AirMax
Yes.
and
Yep.
shooting through some trees and having pretty good success.
We're shooting through very heavy trees. Yeah.
Good.
When the leaves are up, we get about half the bandwidth we normally do.
Right.
But yeah, I mean, we keep them up year round. I can
Have you done any actual, like with active controllers instead of multi-sync controllers? I'm shooting over any of the PTP.
I did it our first year. I shot from a Pi across to an F-16, and it worked fine. But I was just doing just a basic mega tree.
Yeah, basic stuff. Yeah.
Once we started expanding out, that's when we just started moving everything over to Culps.
Yeah,
But actually, now that I think of that, I will go out, like when we're programming, I'll go out with my laptop and send from xLights, which basically is doing that. We're at a point now that can get fun. Trying to have a computer spit all that out in real time. So I see a little bit of lag, but I blame some of that on outdoor Wi-Fi, trying to stream 247,000 channels constantly. But it's definitely, like, if I just want to preview an effect or something, it works fine. I don't think I'd switch our show's architect for it, but if you're doing, you know, especially if you're going over to a couple props, there's no reason you can't send the data over point to point.
Yeah, I just debate on fiber versus I've done some point to point and just regular standard networking out in shows.
Yeah.
And I got about a 2,500 foot run I got to do. So debating between them, but thanks for your experience. Thanks.
Yeah, it definitely worked. I mean, in our case, we're crossing roads, so we can't do fiber. I mean, I'm running fiber throughout my property to do everything I can there, but it also depends just how much it's going to get beat up, you know.
Yeah.
Fiber buried in ground and pipe, I would probably take any day over wireless, but
this would just be armored fiber laying on the ground again.
Yeah.
It's you know, dirt area, not really woods, but
yeah.
It's anyway, I appreciate it. I don't want to get too much into details.
No. Yeah.
Good to see you using some of that. One thing to be mindful of, these 5AC locos, last I checked, did not actually come with a PoE injector, but like the nano beams do, and that's part of the reason that those locos are so cheap. But
yeah,
you might just have to buy a $15 injector. That's all.
I'm trying to remember now. I think you're right. They don't. the switches we've standardized on are PoE, so we just we use the 48 to 24
Converter.
adapter, and
Yeah.
we PoE power everything.
Yeah.
I can go on for an hour about managing it through how it we do PoE solely so we can manage and monitor the whole show, looks for outages and then tries to self heal. So, just because we can. So,
Thanks for the presentation. I appreciate their
yeah.
extra. Yep.
I was trying to see if I've got up. No, it's not pulling right now. I was gonna try and see what the bandwidth is right now. Right now is usually about the worst time of year, especially because it's raining out. Let's see. Scrolling through the chat. Let's see. Yeah, that's the only that is the one downside with the nano beams is those ones are only or sorry, the the locos are definitely 24 volt only. I know I know there's one or two oddball Air Maxes that'll support true 48 PoE, but most of them are 24 volt because they're designed to go up on towers and they don't want as much loss with it. Um, so definitely, if you're doing PoE, don't just plug them straight in because you can fry them real quickly. Let's see, scroll. Yeah, so doing switch back to your home network, that's a great way to do it too. Especially if you're not trying to do Wi-Fi. Like I you know, I highly discourage I discourage trying to do controllers over Wi-Fi. There are some scenarios that work fine, but hardwiring everything back to switch and going back to your home network, that works fine too. There's nothing wrong with that. Especially if what's sending it, as long as if you're sending full show data, that stays on that switch and you're not trying to send it through like your computer connected to the router and then that switch connected to the router, you can definitely isolate it that way, and that works as quite well too. So it's all just how much resiliency do you want versus the trade-off of configuring it. So you know, in our case, once we get it up and going, we like, keep it isolated. If I'm pushing my file, I just connect my laptop to the SSID for the show and then push it that way. That's how I think I have it actually shown on here. Like one of my neighbors who helps program with me, he actually has a Ubiquiti WAP in his house that just lives on our show network solely so he can push xLights straight to it. And that works really well. So there's a lot of different ways you can approach it. So
Anybody else have any other questions? Well, Kevin, I want to thank you for filling in tonight. Great
Yeah, no worries.
presentation, and I know it won't be long till a lot of people start asking about network stuff. So, thank you again.
No problem.